Okay, so this first one for factoring uses something called substitution to help turn it into a normal quadratic. So we use u substitution, and what that means is we make this in the form of a quadratic. So quadratic means we want something to be x squared plus x plus some constant. We can do that here if we consider x to the 6th is the same as saying x cubed squared. And then this middle term is just a plain x cubed. The last one has nothing on it. So we can use something called u substitution where we say, and you don't have to use the substitution, it just helps make it easier to see. But we're going to say u equals x cubed. Well, now we can sub that back in. X cubed turns into u, so we just have 2u squared minus 2u plus 1. Now this should look like a fairly easy factorable problem. And to factor this just turns into u minus 1, u minus 1, or we could say u minus 1 squared. Now the last step, just sub that x cubed back in. So this factors to be x cubed minus 1 squared. This is another factor by grouping problem. So in this case, underline the first two, underline the last two, and we'll look for their GCF. So the GCF of the first two is x squared. For the second two, the GCF is just 1. They have nothing else in common. So we take the x squared out of the first two. You're left with x plus 2. Now here's the tricky part where you have to be careful of this symbol in here. We take that 1 out of the second two, but that's negative makes it a -1, which means the signs change. So that turns into a normal x. The -2 divided by -1 turns that into a plus 2. So now we take out our GCF of x plus 2, and we're left with x squared minus 1. This would be the ending point, shouldn't say should, but you should notice that this x squared minus 1 is a difference of 2 squares. So we can take this one step further to go x plus 2, x plus 1, x minus 1.